a lot of organizations that we do the CSI program for have a pretty similar pattern of building some kind of an app that you as their customer use on a computer, a laptop, mobile phone, doesn't really matter. What's interesting though is in addition to making their own app, they have all of this stuff that goes along with it that allows it to run. So when you open up the website and you go there and start using the app, the traffic that goes to the organization usually follows a pretty detailed path. And so I'm going to talk about it while I draw it out here. But the first thing it usually goes through is some kind of an edge node that usually has web application firewalling capabilities in it. And that basically just means that it looks for common things that look like attacks and drops them. And that's it. And so in order for you as an attacker, who we will put down here, and you know they're an attacker because they're grumpy and they're growling. And so in order for this attacker to get their attack all the way through to get to the thing that they're after, inside the organizations, and this is a pretty typical stack for organizations to use. In order for them to get to the data here in the database that they actually want, they have to go through all of this other stuff to get there, right? And making this problem harder is that everything inside here is typically inside your production network that you try to segment off and have be separate. So when we come in, the thing the customer tells us that they're worried about is an attacker being able to get to data that's back here. So let's talk about a way that we found an attack path this has actually happened a few times, but when we start doing the continuous security inspector program, we are looking at lots of these different areas, right? We're doing a deep dive on the application itself. We're looking at the way the web application firewalls work. We're looking at that first web tier where traffic comes all the way through. We're looking at the actual application itself, and then the platform it runs in on, and then of course the database. So pretty typical. What we'll see is we'll be doing investigations of the app itself, and we'll realize that a bug exists on this application that allows us to send a particular package to this user. And when that happens, we are able to extract their identity, their credential for the web application. And so that's usually the first thing. So now an attacker has this identity of a real user that they can use to try to get access to the data going through this chain. The problem then, of course, is anything that they do that looks like an attack, the web application firewall will knock down. And this particular, a lot of apps have this mechanism, we'll draw that with a little lock here, hopefully it looks like a lock, where it basically every request that comes in gets verified, and if it doesn't have this sort of signature that came from the application, it gets dropped too. And so in order for you to send anything through here, you have to be able to figure out how you're going to defeat this verification mechanism. And then you still have to find something in the app, some kind of a vulnerability you can use that then allows you to get access to the database or run a command on the server. So in doing this in the Continuous Security Inspector program, our teams found a vulnerability in the application that allowed us to do this credential extraction, among other things. We then also found a bypass here in the web application firewall that allowed us to completely bypass any protection that it was doing. So we knew how to get, so in our scenario, step one, we stole this credential. So now the attacker, who is really now a non-defender, pretending to be an attacker, has a way to get their traffic through the web application firewall. No problem. The next thing that we did was we examined this particular locking mechanism that prevents modified traffic that isn't directly from the app to go through, because that's what we're going to need to do if we're going to get something through to steal some data out of the database here. We found a way to do that in a different assessment. So we added that capability to the list, so the team now knows how to modify their requests any way they want and get past this web structure. One of our teams was doing a source code review of this application and found a problem that this app had where there was an old debug function left in that basically still allowed us to run, in this case, Python code. Whatever we wanted to submit as part of that request, we could execute that would then actually run on the server platform itself. Now, the server platform itself has username and password that gets us to the database. So the team was able to steal a credential, then make requests that bypass the web application firewall and the verification signing on the web tier. that then exploited a problem in the application server to run a command on the server itself that had credentials that gained access to the database, and then used a capability we discovered that allowed us to send the data outside of the production network without having to go back through the web tier, finding our own command and control channel that allowed us to exfiltrate data. These are all things that were on their own initially, like separate assessments, that by developing both a list of capabilities and vulnerabilities, the team was able to put together a chain of events that led to the thing that the customer was most worried about happening.